All right, let's just jump right in. Welcome to this explainer. Today, we're taking a seriously fascinating journey into the microscopic engineering of the human body. We're zeroing in on an organ that pulls off absolute miracles of fluid dynamics every single day. And to really bring this to life, we're going to be using some stunning visuals from a realistic 3D video model to kind of freeze frame the action and explore this microscopic magic.
So, 150 quarts. That's about 142 liters, which is honestly just a massive volume of blood. And that's exactly what passes through your kidneys every single day. It's like this incredible industrial-scale purification plant tucked right beneath your ribcage. It takes that massive flood of fluid and efficiently compresses, filters, and refines it down into just 1 to 2 quarts of urine. Pretty wild, right?
To figure out how your body actually pulls off this staggering feat, we're going to trace the exact journey of a single drop of blood. We'll start with the body's master filters, move on to the glomerular gateway, check out the proximal powerhouse, dive into the loop of Henle, and finally wrap up with autoregulation and fine-tuning.
All right, part 1, the body's master filters. Let's get a quick overview of renal anatomy and the sheer demand placed on it.
Now, despite weighing only about 150 grams each, which is roughly the size of your fist, by the way, your kidneys are incredibly greedy. They actually demand 20% of your entire resting cardiac output. That means a whole fifth of every single heartbeat is dedicated entirely to feeding this hungry filtration system.
Once inside the kidney, that massive blood volume is handed off to what is undoubtedly the star of our journey today. Meet the nephron. You actually have about 1 million of these microscopic functional units inside each kidney. They take on the massive responsibility of cleansing your blood of toxins and keeping your fluids perfectly balanced through filtration, reabsorption, and secretion.
But here's the thing, not all nephrons are created equal. About 85% of them are what we call cortical nephrons. They mostly hang out in the outer layer of the kidney and have these relatively short loops. But then you have the other 15%, the juxtamedullary nephrons. These guys are the specialized heavy lifters. They feature these extremely long loops of Henle that dive way down deep into the inner renal medulla, which is absolutely crucial for creating highly concentrated urine.
Moving on to part 2, the glomerular gateway. This is the high-pressure portal where the actual filtration begins. The crucial point to grasp here, and this is beautifully modeled in the realistic 3D video we're exploring today, is that unlike most organs, the kidney uses a specialized portal system. It's got 2 consecutive capillary beds. First, blood coming in from the afferent arteriole hits the high-pressure glomerulus for some heavy-duty filtering. Then, rather than draining straight into a vein like you might expect, it moves through an efferent arteriole and into a second, low-pressure network called the peritubular capillaries. These are perfectly designed for reabsorbing all the good stuff right back into your body. So as the blood squeezes through the glomerulus, we hit what's called our filtration fraction. Interestingly, only 20% of the plasma is actually pushed through the microscopic sieve of Bowman's capsule to become raw filtrate. The other 80%? It just flows right on through the efferent arteriole, waiting downstream to basically sweep up all the nutrients we want to keep.
That brings us to part 3, the proximal powerhouse, the cellular engine of bulk reabsorption.
A staggering 65%. That is exactly how much of the filtered water and sodium is immediately reclaimed right out of the gate here. Think about it. If the proximal tubule didn't aggressively pull this fluid back into your bloodstream instantly, you would literally dehydrate in a matter of minutes. No exaggeration.
If you imagine zooming into our 3D model right down to the cellular level, you'd see this tubule is lined with these block-like cuboidal cells featuring a super dense brush border. It's basically millions of tiny microvilli acting like a highly energized sponge. Because they're packed with mitochondria producing ATP, which are essentially cellular batteries, they have the raw power to actively reabsorb 100% of your filtered glucose and amino acids.
Next up is part 4, the loop of Henle. This is the deep medullary dive and the countercurrent multiplier. Here there's an absolutely incredible division of labor. It's basically a tale of 2 limbs. The descending limb is highly permeable to water, but it completely blocks solutes. But then, once you round that hairpin turn at the bottom, the ascending limb does the exact opposite. It strictly traps water inside while aggressively pumping out sodium and chloride salts into the surrounding tissue. And this division of labor builds into something truly spectacular, the counter-current multiplier. By pumping salt out of the ascending side, your kidney creates this highly concentrated, hyperosmotic, meaning extremely salty environment, deep down in the medulla. All that extra salt physically draws the water out of the descending limb via osmosis. It's literally using salt to pull life-saving water back into your bloodstream. How cool is that?
Because of that loop of Henle and the downstream collecting ducts, a massive 99% of all the water originally filtered at the glomerulus is ultimately rescued and kept right inside your body. It is biological efficiency at its absolute finest.
And finally, Part 5, Auto-Regulation and Fine-Tuning. This is all about how the kidney protects the filter and adjusts the flow.
Through a couple of brilliant, localized auto-regulation mechanisms, the kidney acts kind of like its own smart thermostat. First, you have the myogenic mechanism, where stretch-sensitive smooth muscles in the incoming arteriole can actually feel your blood pressure rising, and they physically contract to protect the fragile filter. Second is tubulo-glomerular feedback. Here, specialized macula densa cells literally taste the salt levels inside the tube. If things are moving way too fast, they release ATP to constrict the vessels and slow it all down. It perfectly stabilizes your filtration.
However, as you might expect, external factors can totally override this delicate system. Taking high doses of everyday NSAIDs, like ibuprofen, actually physically constricts your incoming vessels, basically starving the filter. Severe dehydration? That drastically drops your overall renal blood flow. Even a kidney stone creates a physical obstruction, causing back pressure that fights right against the filtration process. So while the system is remarkably resilient, your daily choices and environment deeply, deeply impacted. Which brings us to our final thought for this explainer. Considering the 150 quarts of blood passing through this microscopic gauntlet every single day, what daily habits can you change right now to better protect the delicate, continuous balancing act that's literally keeping you alive? It's pretty humbling to think about the relentless, microscopic marathon your nephrons are running every single second. So I'll leave you to ponder how you can better support these silent guardians of your internal oceans. Thanks for joining me, and stay curious.